Good morning, everyone. So first of all, I just want to, because I'm not sure if they've been thanked enough, thank Chris Cash and Chris Brady for bringing this all together. So just a quick round of applause for. This morning, I am here to convince you that that NSF wasn't crazy for funding a project on American Lobster that's comes from a program called Navigating the New Arctic, and to talk a little bit about how we, even though we are not in the Arctic, if you looked at the Arctic Circle lately, are deeply influenced by the things that are happening there. And I'm going to start with this figure, which came out a couple of weeks ago. If you haven't read the Lobster Stock Assessment, it's a real quick 800-something page read. That is a tremendous document, and I just really want to thank the folks in the room that were responsible for that, like Tracy and Kathleen and other folks that were responsible for that, because it's a tremendous document. And I want you to sort of maybe even close your eyes and imagine that you're on this $500 million cruise ship with about 5,000 passengers that really need to get someplace. And this is the information that you have. This figure in some ways encapsulates for me the whole Navigating the New Arctic. This is the exploitation rate on lobster, and a really, really key figure in the Atlantic States Marine Fisheries Commission, that said overfishing is occurring. This is the exploitation rate. And that exploitation rate, you can think of the numerator of how many we're catching. So a lot of what you're going to hear about, the social indicators, the bioeconomic modeling, the sort of social side and the socioeconomic side of this is in the numerator, and the denominator is how many are there, right? And so a lot of the population dynamics, the oceanography that you're going to hear about later today is in the denominator. And so those two things come together to create what our picture is on the ship. And I've just been obsessing with this figure, right? Because we're like right here on the threshold as of this year and this assessment. And half of the gray line is above that, and half of the gray line is actually near our target. So we're on that $500 million ship with 5,000 passengers that need to get someplace, and it's really foggy, and that's the color of that fog right there. And I think that the key today is thinking about the tools that we need to, reduce that fog. The American lobster fishery is one of the most fascinating natural resource questions, I think, on the planet Earth. And one of the reasons for that is that I'm on that ship, and if I turn the wheel really, really hard on that ship, it takes 8 to 13 years to know whether I made the right decision. And that turns out to be longer than any political cycle that we have in this country, right? So, which I think makes this inherently much more difficult, right? Because I can protect spawning stock biomass, but it takes 8 to 13 years before those eggs become a harvestable biomass later on. And so we need both at once to figure out these early life history stages, which a lot of people are doing here, but also the day-to-day of what today's stock is looking like and how much we're going to let people catch. I would be remiss if I didn't acknowledge Lydia White, who has done an amazing job compiling the landings for looking at both the U.S. and Canada, and just to think that this is the dynamic that we're in, right, with roughly a peak in 2016 in both the U.S. and Canada. But the difference between this, I'm going to call this purple and this teal, the difference between these lines is growing, right? I think we used to be in this 50-50 situation. I'd say, Lydia, right, we're 70-30 now. So this resource is, it's on the move, and it's super dynamic. This is a super cool figure that Lydia put together too, but just to remind ourselves that this project sort of crosses the border here. But these are the population dynamics. I like the Quebec one, right? Because it's about 8-fold increase in the resource in Quebec. Now, it's starting at a much, much lower biomass than some of these other places. But what's happening here in the Gulf of Maine is also happening in the Bay of Fundy, and we see it on the Scotian Shelf. So these dynamics are being replicated sort of up and down the coast. One of the reasons that we started this Navigating the New Arctic project was this rapid warming, right? And Andy Pershing published this paper that so many of us use and cite and launched 1,000 ships, and Kathy Mills has been has published some amazing papers on this too. So this is the emphasis. We had this sort of rapid warming, and I think over time we've been able to think of that rapid warming less like rapid warming and maybe more like an oceanographic regime shift. We were in some world pre-2008, and now we're in this new world post-2008. And it took us a long time to figure that out. Andy published that paper in 2015 with an endpoint of 2012. It wasn't until probably 2021 when we started to get some more information as to potentially why this was happening. And that turns out to be 10 years after it's happened, right? So it takes a while for us in the, I guess, ivory tower to look down and get that view, right, of things. And this is, you know, the reason for how complex things are, and the reason that we are connected to the Arctic is this Labrador current that Chris Brady mentioned earlier, fueling this slope C that is some combination of Gulf Stream water and some combination of this Arctically sourced water. So some days we can look like the Arctic, and some days we can look like the Chesapeake. And these two water masses mix. And it wasn't until this paper, which is super interesting, in 2021 by Gonçalves Neto, that looked at satellite altimetry, looked at the sea surface height at the tail of the Grand Banks, which is where this water is coming in right here, and did some really interesting work to show that the sea surface height at the tail of the Grand Banks jumped up roughly in this 2008, 2009, 2010 time period. And at that time, the hypothesis was that some of this Labrador slope water that made the Gulf of Maine colder than any other body of water on the US East Coast was getting impinged by the North Atlantic current, or impinged by the Gulf Stream North Wall, and that this had generated a real strong change. By the way, this ends in 2018. Later on, I asked J.D. Poulter of URI to replot this, and so I have the updated information to today, which is like, you know, super interesting. So this is sort of the conception of what we think has happened, and a lot of it comes from North Atlantic circulation, which Patrick Alexander will start talking and helping us with, and then John will end that. So we'll have that conversation. The water comes down here and enters the Gulf of Maine, and then deeply affects this fishery that we all care about. And the result was that with this impingement of water at the Labrador slope water, we have less Labrador slope water delivering to the Northeast Channel, and we have a smaller slope sea in general, and therefore it's a lot more dynamic with shorter volume. This is a cool paper that Kevin Friedland did, where he looked at the Northeast Fisheries Science Center trawl survey bottom water and did a change point analysis. And in hindsight, because hindsight's really, really clear, we could see a change point in 2008 in the outer Gulf of Maine, and then the inner Gulf of Maine about 2009 was, you know, fundamentally different. By 2010, it had reached Cape Cod and out to George's Bank. And so in hindsight, we can literally see this change actually flow through this whole lobster system. And that's me putting arrows on things. This is not the full story. Our colleagues in Canada have some really cool papers that are talking about the shelf break jet, because oceanographers come up with cool ways of describing things. But this is this flux of water from the Labrador slope water. And one of the things they did, and I'll zoom in here, is they look at the density, or in this case, the sea surface height between the Scotian shelf and the tail of the Grand Banks. And they noticed that over time, with a rapidly warming North Atlantic and a less warming South Atlantic, the difference between Scotian and tail of the Grand Banks, which drives a lot of the Labrador slope current, is getting shallower. So this slope is the old slope and used to drive Labrador slope water, but as one part warms and the other part doesn't warm as quickly, this slope is lessening. And so there's a combination of this impingement and just a general slowing of the Labrador slope water over time, which we're all dealing with. So a couple of cool things happened and a couple of not cool things happened as a result of that. This is a paper by Andrew Good, but he demonstrated that post-2010, all of this habitat in down East Maine became settleable habitat, whereas we wouldn't find a lot of settling recruits in down East Maine before. All of a sudden, post that period of time, settlement looked really, really good. But the not cool thing that happened, and Josh Carloni and other folks in this room have talked about, and this is from Burdenshank in the stock assessment too, is that we saw this decline in Calanus. So at once we had this really great expansion of settleable habitat, but the environment itself potentially became bad for the lobsters that are in the water column that are potentially feeding on Calanus, as Alex Asher and other folks have pointed out. So what does it look like now? I thought this, no one's seen this figure, so which is pretty exciting, but this is that sea surface height at the tail of the Grand Banks again, and I asked J.D. Poulter to replot it. This is what the original Gonsalves Neto paper said. And what's really cool is that about last year, 2023, 2024, it dropped to what what would be considered normal in older times. About a year ago, the Gulf Stream didn't allow more Arctic water into the region again. And there's a lot of evidence suggesting yes. So this is the percentage of Labrador slope water and or warm slope water in red, and the Labrador slope water here in black. And it seems like, and this is a paper by Nick Greger, that there's more cold water coming into the Gulf of Maine recently. Now, whether that's a blip or whether that's something we're going to see in the future is really, really, really important for people to understand, because it, I think, affects the ability of protecting spawning stock biomass and getting that to create new settlers. To be the last, I'm trying to do a 40-minute oceanographic talk in about 15 minutes. So this is I swear my last one, but this is a very cool figure that Andrew Good has come up with. This is not a spawner-recruit relationship, but it's kind of as close as we can get. So this is the annual landings in the Bay of Fundy, Northeast Gulf of Maine, Southeast Gulf of Maine, and Southern New England. And Andrew has related it to settlement. So in a perfect world, this is the way the world would be: more annual landings, more spawning stock biomass, more settlers. And it sort of holds true here in Southern New England. But if I zoom in on the Northeast Gulf of Maine, I think what Josh has described as sort of this great disconnect. Why are we getting so much landings and so much spawning stock biomass, but not a lot of settlers? And one of the hypotheses is that the food resource like Calanus is not good for some of the larval lobsters. What's kind of cool is if you put little dates on here, and I know you can't see them, so I've highlighted them, but in this 2012 to 2017 period, where this tail of the Grand Banks really has been impinging Labrador slopewater, you see this poor relationship. And then the last couple of years, 2022 to 2023, you can actually see it climbing back up this line. And it's really important, because if fishery managers only lever, and again, that wheel on that big cruise ship takes 8 to 13 years, it'd be nice to know that if I protect spawning stock biomass, I will get more settlers later on. It'd be really great to know that for sure. So very, very few things in this life are for sure. So that's my brief introduction to what we're trying to do, because we understand this is like this is Ostrom's dream situation, right? We have a fishery and a fishing fleet that is affecting the resource, right? So the stock assessment says, right, fishing is affecting the adult population. And then we have all this environmental change that's affecting these early life history stages. And so the idea of the project that you're about to see, these 3-minute vignettes, is that we need to try to understand all of this. And that includes the impact of a changing cryosphere on North Atlantic circulation. That North Atlantic circulation is affecting phytoplankton and zooplankton, like the Calanus that we've talked about here. And in turn, that's affecting the ability of the spawning stock biomass to generate settlement, which is affecting the adult population, and then back into the fishing behavior. And I could easily, thank you, Miguel, for sending this up to me, but I could take this bioeconomics and fishing behavior and social indicators and reverse this arrow back down in here on the lobster population dynamics too. So without further ado, my 15-minute, 40-minute lecture, let's get to Patrick and talk about cryosphere.